Hey everybody, welcome to your very first lesson that you're going to have in Algebra 1. Our first lesson for Algebra 1, Chapter 1, Lesson 1 is variables and expressions. Our job is to be able to write a verbal expression for every algebraic expression that we see. We need to be able to write algebraic expressions for verbal expressions. Now right now, if you're looking at this might not make sense to you, but all a verbal expression is verbal expressions are usually the way we would speak mathematically, where an algebraic expression is how we would write it mathematically. So really what this really means is all we're doing is taking words and writing it in numbers, taking numbers and writing it in words. And those are our two objectives for today. And the standards that we're going to be addressing is the Algebra Standard A.SSE 1A and A.SSE 2. Alright, ladies and gentlemen, so you have just looked at what our objective is for today, but one of the things that we should always look at after we look at our objectives is some of the vocab words that we're going to be seeing in today's lesson. The first vocab word that we're going to be seeing in today's lesson is a variable, and a variable is a symbol that's used to represent an unspecified number or value. Usually, typically in algebra, what we're going to see variables as is we're going to see them as letters that we just don't know what they equal until we go about solving them. An algebraic expression, it's an expression that consists of one or more variables. So if you see a problem that has many variables and it does not have an equal sign, that's an algebraic expression. Typically, algebraic expressions will at least have one arithmetic operation, and what I mean by that is I mean by adding, subtracting, multiplying, and dividing, and a variable. So if you see some type of adding, some type of subtracting, multiplying, or dividing in a variable, you're looking at an algebraic expression that has arithmetic operations. The next vocab word that we're going to be looking at is term, and a term is a number, a variable, or a product or quotient of numbers and variables. So term is usually what I would say separate. Terms are usually numbers that we would normally separate by an addition or subtraction sign, or they deal with multiplication or division. A factor is a number or numbers that multiply. So if I were to say the factors that multiply to make 6 are 2 and 3. 2 and 3 are factors of 6. Also 1 and 6 are also factors of 6. The product is the answer that we get whenever we multiply two numbers together. So the product of 2 and 3 is 6. An exponent indicates how many times a number is being multiplied by itself. So usually when we see something that has a power, that power tells us how many times we're seeing that number being multiplied. And that brings us to our next piece, which is base. Base is the number that is being multiplied. Anytime you see a number, let's say I'm going to write it over here. If I said 5 to the third power, this means 5 is the number that's actually being multiplied, where 3 is how many times we're multiplying 5 by itself. So if you were to write it out, it really looks like 5 times 5 times 5. The exponent is the little small number up top. The base is the big number down below. And again, the base tells me what number is being multiplied, where the exponent tells me how many times that number is being multiplied. So if you were to actually read this is actually 5 to the third power. Alright, hey guys, this is our first question that we're going to be looking at. This is our first example. Anytime we see an example on the board, our job is to first pause the video, write down what we see, and then attempt the problem. So in this problem, our first example says that we need to write a verbal expression. Reminder, based on our vocab, a verbal expression is really how we would speak the words. It says write a verbal expression for 8x squared. Now you can't just write 8x squared. Whenever we're writing verbal expressions, we have to talk about the operations that are happening in a verbal expression. So in this case, we have to talk about the 8, we have to talk about the x, and we have to talk about this little 2. And whenever we do that, we have to actually write that in words when we're writing verbal expressions. So if I were to do this, I'd be reading this as 8. That's the very first thing I see. But then the next thing we have to ask ourselves is, a number is next to a variable. It can't just be just 8x. What is the 8 doing to the x? And in mathematics, last year we learned that a number next to a variable actually means that it's multiplying. So I could write it as 8 times x. That's really what's happening between the 8 and x. The 8 is multiplying by x. Now we have to talk about that little 2. Well, that's an exponent. And exponents tell us how many times something's being multiplied. So in this case, it's 8 times x, and we would normally write this as to the second power. This is just one way that you could write it. The other way that you could rewrite this is you could write that it's actually 8 times x squared. Because sometimes when we're talking about the second power, we can actually use the word squared. Alright, so here is our second example. If you want to try this example on your own, by all means, please pause the video. See if you can answer this before I actually go through how to do it. I'm actually just going to go ahead and go through this and show you kind of a couple ways that you could write this. So the first way is we have to read the problem. It says write a verbal expression for y. I would read that as y to the 5th power minus 16y. And again, whenever we're actually writing it using verbal expressions, we have to write down every operation that's happening. Operations mean addition, subtraction, multiplication, division, and so forth. So we have to write down what all is happening with each one of these numbers. So I'm just going to start off with what I said. Y to the 5th power minus 16y. So a lot of you would probably write this. Y to the 5th power minus 16y. Technically that is wrong, because if we look at this problem, y is to the 5th power. We are taking away 16, but what is 16 doing with y? So I have to say exactly what's happening with 16 and y. So I'm going to erase that y, and I'm going to say that 16 is actually multiplying 16 times y. There's another way that you could actually write this, and we're going to talk about that right now. This is the difference, so we can talk about the difference. In mathematics, the word difference means subtraction. So I'm telling you right now, right from the very first two words, that we have subtraction happening. There's a subtraction problem happening. It's the difference. Now that I said the difference, I can talk about the two numbers that are representing the difference. So it's the difference of y to the 5th power and 16 times y. So this is just another way that we could actually say this. This is the difference of y to the 5th power. So we have y to the 5th power. Difference again means we're subtracting. And then 16 times y. Those are the two ways that you could write this problem. Whichever way that you prefer, that's absolutely okay. These are just two different ways that you could. Alright guys, for the third example, I'd really like you to pause the video and try this example on your own. See if you can use some of the things that we just talked about to be able to write this verbally, how you would say it on your own. Alright, let's go through this. So when reading the problem again, we would say, write a verbal expression for 7a to the 4th power. We can't just say a to the 4th power. We still got to say what's happening between 7 and a. So the one way that you should have wrote it, or you could have wrote it, is 7 times a to the 4th power. And really, that's about the only way that you could say this problem. So if you got it right, good job on you. Let's go ahead and try another one. Alright, so for your fourth example, again, this is one where I feel like we've kind of did two problems. I feel like you guys could probably do this on your own. So again, pause the video, try this on your own. We're going to go over it here in a couple seconds. Alright, let's go over this problem. So for this problem, I'm reading it, write a verbal expression for x squared plus 3. So the way I just spoke it should technically be right. X squared plus 3. Ooh, my R is kind of weird there. But x squared plus 3, that's one way that I could have wrote this. Another way I could have wrote it is x to to the second power plus 3. And there's actually one more way that we could actually write this, and it kind of deals with the way we did a previous problem with the word the difference. But in this case, we can't use difference because difference means subtraction. So the other way that we could write this is we start with the word the sum. And what sum means is sum is the answer of addition. So we're going to talk about the answer of addition between two numbers. So the sum of x squared and 3 is the final way that you could write this problem down. So these are the 3 different ways that you could maybe have written this. As long as you have any one of these 3 ways, you're absolutely great and you got it. Alright, ladies and gentlemen, for your next part, I'm actually going to post some of the key concepts that we need to be looking at based on words. It's going to do addition, it's going to do subtraction, multiplication, and division, and some of the words that they talk about that you could use in one of your phrases as you're speaking about these numbers and how to use them. Alright, so we're switching gears now. We're going to go to the second part of today's lesson, and that's our second objective. And our second objective was to be able to write algebraic expressions for verbal expressions. So now we're going to see something written how somebody might say it, and our job is actually to write the numbers that go along with it. So in our first example, or problem that we're going to look at today, is we're going to look at how to write an algebraic expression for 5 less than a number c. Now the big key word here is less than, and this came from your list that you just copied down just a few seconds ago. Hopefully you paused the video, you copied it down, and now we're ready to go about it. So it says write an algebraic expression for 5 less than a number c. Well, before actually trying to approach this, I'd like to ask you, what is 2 less than 5? Okay, most of you probably thought 3, and 3 is absolutely right. But when you actually do 2 less than 5, you're actually taking from 5 first. You would say 5 minus 2 is 3. Does everybody agree that 2 less than 5 is 3? Okay, so since we agree with that statement, maybe this will help us rewrite this. 5 is less than a number c. So we're really taking away from c. So if you were to write this correctly, you would say c minus 5. This is the way it should be written. It's not 5 minus c. I know that sometimes we read the word less than and we automatically think this number comes first because we read it first, minus c, but that's not the case whenever we use the word less than or more than. Those numbers typically actually happen at the end of the problem. So again, if you see 5 less than a number c, I like to flip it into something easy and say, what is 2 less than 5? 5 minus 2, that's 3. So 5 less than c means we probably should take the number 5 and take it away from c. 5 taken away from c. Alright, so here is our next example. Same situation, we're still writing algebraic expressions. In this case, our job is to write an algebraic expression for 9 plus the product, again product means the answer multiplication, of 2 and d. So we're going to be adding 9. But 9 is going to be added to the answer of multiplication. So in this case, if you were to do this, try it on your own if you want. Pause the video, try it. But we're going to answer it here. 9 plus. So that's the easy part. 9 plus. I've covered the first 2 words. The product of 2 and d. So I need to have the answer of 2 times d. Well, 2 times d is 2d. And you're done. You've successfully written in numbers these words. And again, that's algebraic expressions because you see that we're using variables. Alright, so let's go into the challenge problems where you're going to try some problems completely on your own and see how you do. Alright, welcome back guys. So in this one, we're going to read the problem. It says write an algebraic expression for 2/5 of the area A. Now if you can see here, I've actually underlined the word of. And the reason why I underlined the word of is that's my operation. A lot of people tend to miss that word. But the word of in mathematics really just means multiply. So we're going to take 2/5 and we're going to multiply it by the area A. So 2/5 times A is one way that you could write it. Now, I don't recommend using an X for multiplication when we start using variables. I actually recommend using the decimal or the dot for multiplication, just because it doesn't confuse you that there might be two variables. There's just one. So 2/5 times A. Another way that you could actually have rewritten this, you could have just wrote 2/5 A. Both of these are technically correct because, again, if we remember from earlier, any number, so 2/5 is a number, next to a variable just means multiplication. 2/5 times A. Alright, let's go ahead and try our next one. So for this problem, I've actually kind of give you guys more of a challenge problem, and this is one that you're going to see in class that we're going to practice tomorrow. It says, write an algebraic expression for 5 times the difference of 2b and 3. But we're going to be adding 4 plus 4. So the first thing is we want to try to do 5 times. So start with 5 times. Now reminder, the word difference means that it implies that subtraction's happening. So we need to read where's the difference or where's the subtraction happening. Well, the subtraction is happening between 2b and 3. So it's 5 times 2b minus 3. Well, I have a difference happening. But if we remember the rules of PEMDAS from 4th grade, 5th grade, 6th grade, 5 times 2b, that would normally have to happen first. But it doesn't say that we're just going to take 5 and multiply it by 2b, or the problem would actually say 5 times 2b. This actually says that we're going to take 5 times the difference. So that means we need to have the answer of subtraction before we actually multiply by 5. So in this case, this is where we have to actually use a special grouping symbol, and that grouping symbol is a set of parentheses. 5 is going to multiply by whatever answer I got, because in PEMDAS, if we remember correctly, we actually have to solve what's on the inside of parentheses before we actually do any multiplication, addition, or anything that's outside of parentheses. So 5 times the answer of subtraction, and then we're going to add 4 plus 4. And this would be actually correctly written for how we would solve a problem that looks just like this, and we will practice this in class tomorrow. For our last few types of problems that we're going to look at, is we're actually going to look at something that could potentially be a real world example. And in this case, we're going to talk about Mrs. Tony. So Mrs. Tony bought 3 adult tickets and 4 student tickets to ride on the Mariner 1. Again, that's our boat that we have for the school for the day. Our job is to write an algebraic expression that represents the cost of the tickets. We need to assume that adult tickets probably cost a little bit different than student tickets. So we have to come up with the total price, but without actually adding an equal sign, because again, the job says to write an algebraic expression. No equal signs are allowed in expressions. So in this case, we would say that 3 adult tickets. Well, we don't know the price of an adult ticket, so we maybe want to use a variable in this case. So in this case, I'm going to say 3A, A for adult tickets, and 4 student tickets. So I know that 3 adult tickets are going to add to 4 student ticket prices, but we don't necessarily know the price of student tickets. Chances are, though, that student tickets are different than adult tickets. So instead of using the same variable A, we have to actually use a different variable. So in this one, I'm just going to use 4, because that's how many tickets I got, but I don't know the price, and I'm just going to use S for students. So 3 adult tickets plus 4 student tickets would represent the total price that Mrs. Tony would pay to ride the Mariner 1. Alright, and so for our last and final question, I decided to pull Mr. Oliver into this one. But Mr. Oliver bought a bag of candy that cost C dollars, and he gave the cashier a $20 bill. Our job is to write an expression that represents how much money he spent and how much he'll get in change. So we need to write an expression for the amount of change that he will receive. Now, when you're doing price of something, do you add it, do you subtract it from the bill? And so we need to figure all that out and how to work it. In this case, we know that he gave him a $20 bill. So we're going to start with $20. That's his starting amount. But we also know that he's going to take away the cost of the candy that he's buying. Now the cost in this case, we don't know the price of the candy, but we do know that it costs C dollars. So we're taking away C dollars from the 20 that he's given the cashier to figure out how much change he would have left. So it's really just 20 minus C. If you have any questions from these videos that these different questions that we talked about today, make sure that you come into class tomorrow with your questions. We'll spend the time going over these, helping you understand, and we're going to do some practice in class and hopefully make this a little bit more of a concrete idea. Any questions? Have a good day. Make sure you're ready tomorrow. Bring your notebook. Bring this. Let's go.